All right, section 3.5 is entitled Parallel Lines and Triangles. We have two main objectives here. The first objective, I can use parallel lines to prove theorems about triangles. Notice parallel lines to prove theorems about triangles. And then secondly, I can find measures of the angles that are within triangles, both inside and outside of the triangles. So let's look at a few postulates and theorems here and make sure that we understand them first. The first one is postulate 3.2, which is known as the parallel postulate. It says through a point not on a line. So let me start off by having a line right here. We're going to call this line L. And I know that there exists some point not on that line we'll call point A. That I know there is only one, or one and only one, line that I can draw through this point that will be parallel to the given line. All right, so in other words, there's only one line M such that L is parallel to M. This is known as the parallel postulate. Through any point not on the line, there is one and only one line that is parallel to the given line. We have this theorem 3.11, which we're going to come back to later. It's a very straightforward one, but I want to show you guys how it's proven to actually be true. And this one simply says that the sum of the measures of the angles of a triangle is 180 degrees. So if I have some triangle here, triangle ABC, what this theorem tells me is actually something that we already know, which is the measure of angle A plus the measure of angle B plus the measure of angle C has to be 180 degrees. So those three angles have to add, inside of a triangle, have to add up to 180. Within a triangle, we have something known as the exterior angle of a polygon. Now, we're going to focus on triangle side, but this is true for other polygons, quadrilaterals, pentagons, hexagons, etc. Okay, so I'm going to start off with this triangle right here. And if I take triangle ABC, let's call it, and I take one of the sides, I'm going to choose to take side AC and extend it out in one direction. Put a point over here called D. One thing that you may notice is now over outside the triangle, there exists some new angle that we just created. I can do this off of any one of the sides. Okay, by extending it, I create what is called an exterior angle of the polygon. In this case, an exterior angle of a triangle. All right. Now, if I am standing where this new exterior angle is created, then I actually have a name for this angle right here and this angle right here. And those two angles are known as remote because they're right, not next to it, interior because they're inside the triangle angles. So we have this thing called remote interior angles. All right. And again, this angle out here was known as an exterior angle of the triangle, or it could be in general of a polygon. Okay. Now, the next theorem that we have is 3.12, which talks about the triangle exterior angle theorem. All right, so this tells me I've got a triangle. And let's say on this triangle, I went ahead and extended one of the sides out already. This creates for me this angle, which we're going to call 1, an interior angle that actually forms a linear pair with it. And then over on the other side, we have angles 3 and 4, which we just named as remote interior angles for angle 1. What the exterior angle of a triangle theorem tells me simply is this. I know that the measure of angle 1 has to be the measure of angle 3 plus the measure of angle 4. Now, what this does right here is this provides for us a quick way for us to find missing angles either inside or outside of the triangle. You could always go through the whole process of, well, 1 and 2 are a linear pair, 2, 3, and 4 add up to 180, and then figure out missing angles from that. But this is a very quick and easy way, which I'll show you in a couple of examples here in a minute. All right, so let's take a look at the first problem. So it says, what are the values of x and y? We've also got a z in there, so I'm going to go ahead and find them all. When you're studying an image like this, and there are triangles in it, always use the triangles to try to help you figure things out. So the first thing I notice is I have triangle ABD. ABD, and within that triangle, I know 2 of the angles. So I can create an algebraic equation that says x plus 43 plus 59 has to be 180. In other words, the 3 angles of a triangle have to add up to 180. Whoop. Okay, I'm going to go ahead and combine like terms. So I have x plus 102 equals 180, or I find x to be 78 degrees. Now, I notice in the other triangle, triangle BDC, that x and y form a linear pair. Well, I know that a linear pair means that they are supplementary or add up to 180. So I can now say that x plus y equals 180. And by substitution, I know that x is 78 plus y equals 180. And then I could say, well, that's simple. Then y is equal to 102. Now, this is one way to do it. I could also recognize that that angle y was an exterior angle to triangle ABD. And the exterior angle of a triangle theorem tells me that the exterior angle, y in this case, would be equal to the remote interior angles added together. So even if I do it that way, I still end up with y being 102 degrees. Okay? All right, so how about finding z here? Well, in order to find z, I have to know y. All right? Z is not an exterior angle of a triangle. So in order to find z, I'm going to have to rely on the 3 angles of a triangle, y plus 49 plus z, have to add up to 180. I'm going to substitute the 102 in for y, and then solve for z by combining like terms. 151 plus z is equal to 180, and subtract 151, and I get z is equal to 29 degrees. All right, so let's take a look in this second example by breaking down the exterior angle theorem a little bit closely, just so you guys can see how it works so quickly oftentimes. Now, without the triangle exterior angle theorem, if they want me to find angle 1, I would first have to figure out what this missing angle was in the triangle, and then find its supplement, and that would give me angle 1. Or, I know that the triangle exterior angle theorem says this: the measure of angle 1 is simply 80 plus 18. Or the measure of angle 1 is 98. Done. To find the measure of angle 2, well, I would have to first figure out the supplement of 124, then add that to 59, and then subtract that from 180 to find angle 2. Or I can just say the exterior angle is equal to the measure of angle 2 plus 59, and subtract 59 from 124. So that tells me that the measure of angle 2 would be equal to, what is that, 65 degrees. I think I did the arithmetic correct there. Yep. Okay. Now, take a look at this third one. All right. On this third one, these are the kind of problems that you might see like on an SAT or an ACT. So it says, all right, the radar tracks an object, and the reflection of signals off the ground can result in a clutter. The clutter causes the receiver to confuse the real object with its reflection, called a ghost. So the ghost would kind of be down there where D is. At the right, there is a radar receiver at A, an airplane at B, and the ghost at D. How do I find the value of X? Well, if I look at this imagery right here, I can create a triangle between the ground, the tower, and the actual plane. I know that the plane has an angle at 30 degrees. I know that down at the angle on the ground to the ghost is 80 degrees, which is actually forcing an exterior angle of the triangle. So then I know very simply that 80 is equal to x plus 30 by using the exterior angle of a triangle theorem, which I will be able to conclude then that x is 50. All right? So the other part that I want to talk in this lesson about is this idea of something called an auxiliary line. An auxiliary line is a line that you arbitrarily add to a picture that enables you to help be able to complete a proof about it. All right. So in this picture right here that I have, the red line is what is known as an auxiliary line. All right. Whenever you use an auxiliary line, you have to explain what it is and what it does and why you can do it. All right. So we're going to do a proof of this triangle angle function line. And remember, this is very simply that proof that we've all known forever, it seems like, that the three angles of a triangle add up to 180 degrees. We're going to prove it. Okay? So the first statement that I want to make is that line PR exists. All right? So line PR runs through B and is parallel to AC. And what allows me to make that claim is that I know at the very beginning of the lesson, we said that through a point not on a line, there exists one and only one line that is parallel to the given line. That was known as the parallel postulate. This parallel postulate allows me to create this red line. Okay? When I drew that red line now, there are three angles that get created up on top. All right? But I only want to focus on two of them because I know two of them form a linear pair, and therefore I can say would be supplementary. All right? So for example, here's what I'm talking about. I know that the measure of angle PBC plus the measure of angle 3 has to be 180 degrees. All right? And the reason why I know that is because angle PBC and angle 3 are a linear pair. All right? So we know that a linear pair means that they're supplementary, and supplementaries can be written as an addition of two angles that add to 180. Remember, linear pair and supplementary are both pairs. So that's why we have to just define two of them adding together. All right? Now, I also know that this is true, though, from my picture. I know that the measure of angle PBC is the measure of angle 1 plus the measure of angle 2. All right? I know that to be true because of something we learned a while ago called angle addition. All right? So angle addition allows me to make that claim. Now, right now, some of you, I bet, are looking at this saying, I know what you're going to do here, Leonhardt. I know how you're going to make this work, that the three angles are going to add up to 180 degrees. And you're absolutely right. The next step here would be to say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. I know this to be true because I am substituting 1 and 2 in for PBC. So that's called substitution. All right, so now I know that those three angles up on top must add up to 180 degrees. All right, but now what I need to do is I need to figure out how to get A and C into this mix so that I can make that statement. Well, let's see what it is. We know, let me think here. I know that the measure of angle 1 must be equal to the measure of angle A, and the measure of angle 3 must be equal to the measure of angle C. Now, do you know why? The reason you don't know is, remember we created that red line to be parallel to AC. Well, now what we've created is two pairs of alternate interior angles that are congruent. So my claim here, my reason will be alternate interior angles must be congruent. So now what can I do with this A and this C? I can go ahead and substitute and say, well, now I know that the measure of angle A plus the measure of angle 2 plus the measure of angle C must be 180. That's what they wanted me to prove, and I know that to be true by substitution into my proof. All right, I hope this helped. Please complete homework 3.5 and have that ready for the next class.